Welcome to part 4B of our interior room series. In this episode, I'm going to continue adding functionality to the functions we did in part 4A. We're going to be adding a ceiling to the layout. We'll also be adding additional doorways that will break up our maze. We'll also be adding a minimum and maximum to our room types and enhancing the functionality of that so we can limit the number of a specific type of room that's randomly generated, and basically expanding on the features that we created in part 4A. So let's get started. So right now we have a maze algorithm connecting our rooms together, which is great because all the rooms are connected, but in a large room situation, we are going to have a maze, and that could be difficult to navigate and not what you want for certain situations. So what I think we should do is add some additional connections through the layout of the level so that it breaks that maze feel and make that optional. So we'll have a variable number of additional doorways that will just scatter throughout randomly. And then I'm also going to put a ceiling on this. This current layout is great if you want kind of an isometric feel, but for most third person or first person situations, you're going to want a ceiling on this as well. So I think we'll add that to the layout so that we have a more finished look for an interior here. Let's get to work on those two items. For our extra doors, we're going to start in BP level. Let's add a variable here. We'll just call extra doors, and this will be an integer. We'll compile that so we can set the default to 0. Default is 0, so we're good. And then we want to make that visible. That way we can set that in our BP level. We should see extra doors here, and we can set this to some value. I'll set it for 4 right now. And then in our PCG level, we want to pass that here into add doors. So let's go ahead and get actor property. We want that property name to be exactly the same. So I'm going to copy it. Set that there, and I'm also going to change the name of this. So now there's our extra doors. Then we need to add this to our add door. So let's go in there, add that property here. Again, make that an integer, make it visible. And now we see our extra doors here. We can just hook that up. To add random extra doors, what we want to do is kind of a combination of this pick the initial random room combined with what we do in visit room. Here we get a random in range with the whole range of our points, and we have our max indexed set, so we can use that to get a random in range, and that's going to pick a random room. And then we want to pick a random door in that room. The random direction that we'll choose, we want to make sure it's not set as a door already. So what we're going to use here is a new function. We'll want to add this to our completed after the while loop because we want to make sure all the maze doors are already set in our rooms, and so we'll want to add it here before we return the data. So we'll want to make a little space here, and then we're going to want to create a new function. We'll call this add random door. And in add random door, actually let's call it add random doors. Let's do them all here. We'll get our extra doors, and we'll add a for loop. We'll want this to have an exec pin. Hook that up to our for loop, and we'll want this to go from 0 to extra doors. And we want this to happen only if extra doors is greater than 0. Let's check that before we call this for loop, because if we set this from 0 to 0, it's going to happen once. We'll do a greater than 0, and we'll hook that into a branch. And we'll go from 0 to extra doors minus 1. So if we have 1 extra door, we'll go from 0 to 0 doing this once. And if we have 10 extra doors, we'll go from 0 to 9. So for each iteration of this loop, we want to get a random integer in range, and that range is going to be from 0 to max index. And that's going to be our random room. So let's promote this to a local variable. Oh, whoops. I made this a macro and not a function. I want this to be a function. Sorry about that. All right, so call it add random doors 2 for now. I'm going to copy all this over so I don't have to do it again. Put that here, paste it in, hook this up, delete this, rename this, promote to local variable. And that's going to be random room. So when we added doors previously, we didn't have to worry about whether there was a door in the direction we were adding or not, because we were always going to an unvisited room, so we knew there wasn't already a door there. But when we're doing this just randomly, we need a way to check if a door already exists where we're trying to add one, so that we don't add a second door in the same place. Not that it would add a second door, but in order to get the correct number of doors, we want to add 4 additional doors. If we add one of those doors where there's already a door, well, we're only going to add 3 additional doors, and that doesn't really accomplish what we're after. We need a way to check where the doors are already. So we're going to have to create a structure that we're going to add to track our doors, because currently, if we go back into our visit room where we're adding the doors, we add the doors here, and we only add those doors to our points. And reading this back out of the points is not going to be the easiest way to get that information. So if we were to try and get the location of our doors back out of our PCG points, you don't have to follow this. Let me just show you what happens. We get our output copy, and then we get a copy, and then we break this. And you look at what's available here, the added Boolean north, south, east, and west are not available here. So we can't use this PCG point structure. And instead, we're going to have to create another structure and store the directions of doors we already have, and then check those. So let's go out to our content browser, into our PCG, and we're going to just add a new structure here. So blueprint structure, and we'll call this S room struct. And then let's open that up. Then inside that structure, call this doors. And we'll just have a structure here with E direction. We'll make that an array. And then whenever we add doors, we'll just add to this. Then in our PCG BP add doors, we'll have a new variable here we'll call rooms. And that's going to be a S room struct. We'll make that an array. Go back to our execute with context. We're going to resize that right here, just like we did with these other arrays. Getting room here to add stuff's getting a bit tricky. Okay, then in our visit room, in our add doors, we want to do the same thing we're doing here. We want to do this with our new room structure and add the directions that we're adding here to both our current room and our neighbor room. The current room's really easy. So for this, let's create a little function. We'll call it add single door. And then we'll get our room structure. For inputs, we want our index, call that room index, and we want the direction, which is an E direction. We want to get a reference to this current room. Inside that reference, in that structure, split the structure pin, we see we only have an array of doors. With that array of doors, we can simply add. Technically here we should check if the direction that we're adding already exists in this array. That would make our code more robust. But if we carefully add to this array, then we don't really need to do that. So let's also add an option here that we can add the opposite direction. Create another input here. We'll call it opposite, and that'll be a Boolean. So we'll use that to invert our incoming direction. So from that, let's create a branch. On false, we'll just do what we just set up here. That's going to be our normal case. On true, we want to do a very similar thing here to what we have done, but instead of adding this, actually we can use the same get here. But what we want to add is a 3 select. And we'll hook our direction up to the index. But instead of this being set up this way, yeah, there we go. We can use the literal enum direction. We'll need 4 of these. And so we'll hook south to north, west to east, north to south, and east to west. And that way, each of those will invert. And then we just need to clean this up a bit. That looks a bit better. Unfortunately, it's not possible to have this with no crossing lines, but at least that's a little more clear. File and save that. Now if we go back to visit room and into add door, we can pull out add single door. We can add that either at the beginning or at the end. I think it's going to be a little more clear if I add it at the beginning. So we'll do that here. I take this neighbor room and I'm going to move it down a bit. And we'll just drag in our add single door. And we're going to need 2 of those. Drag it in twice. And we'll hook that up right here. And the first room is going to be our current room. And the second room is going to be our neighbor room. Our direction is going to be our neighbor direction for both of them. But for our neighbor room, we want to check the opposite. And then we can hook that up here. And so that's going to set our variables for tracking those doors. Go to our add random doors. In this, when we get our random room, we can now get our room structure. And we can get a reference to our random room. And now we can look at this variable here, split that, and then we can for each. So to pick our random direction, let's create an array. I'm going to call this available directions. And that type's going to be an E direction, and it's going to be an array. So set that as E direction and select array type. And then in available directions, we'll get that, and then we're going to add. And we're going to add all 4 directions to that. We'll connect all those together. We'll get the room from the rooms array and get the doors from that, and we'll loop through those doors. Then with available directions, we're then going to remove any existing doors. So we want to remove item, and the item we want to remove is this array element. So we'll add all 4 directions here, and then we'll remove any existing directions. So then after that's complete, then we can just take a random index from available directions. So we'll want to add the door in that direction using our add door macro. For add door, we need the current room and the neighbor room. So we're going to have to find the neighbor room and make sure that this direction is valid, and then we can go ahead and add the door. Let's add a new function we'll call find neighbor. And in find neighbor, we'll take a room index, which is an integer, and we'll take the direction, which is E direction, and we're going to return the neighbor index, which is an integer, and valid, which will just be a Boolean. So if we look at our find unvisited neighbor, all this messy logic right here is to determine which index is the neighbor in all 4 directions. So we can copy that logic and bring that into our find neighbor function. We'll clean this up in just a second. We need to determine which set of logic we need to use based on our direction. To do that, we can use a switch. So this switch will take our direction in, and then it's going to give us 4 different possible paths to go out. And then we'll hook up the correct logic here to each of those outputs. For north, we took our room index and we subtracted off this truncated max x value from max xy. Let's take a look and make sure we get these directions correct. Go back to find unvisited. So yeah, the first one was north. The second one is south, the third is east, and the fourth is west. We'll use those same ordering in find neighbor. Our north and south logic here, and this is our east and west logic after that. Let's pull all these down here with our room index. So for our north south, we needed to check our is valid macro. And we can say is valid neighbor into the name of this. Make that more clear. We're going to return valid. We can just hook this node up here, and then we can hook north to the return node. So this is our north logic here. And if we duplicate this return node, we can just have a return node for each logic. And that way we can return both of these values correctly for each situation. We'll test if this is valid. And in this case, this is south. So for east here, this should be our test right here, and this modulo needs to be hooked up to our room index. And we don't need the branch. We can just return the is valid. This value went with this test. So this west index here, let's bring west down, hook that up to the node, down a little bit. And that's our index there, and this is our is valid. Try and clean this up a little bit. Afraid there's no way to make this truly neat. Get our room index this way, it'll help clean up these lines. Let's do that instead. Break all those. That's a little bit better, about as neat as I can make it right now. File and save that. Now we have a find neighbor function. We go back to add random door. When we get this direction, then we're going to want to find neighbor. Doing this on completed. This is our room index. And this is our direction. Now, if this is valid, then we can go ahead and add that door. Then we have everything we need. We have our current room, our neighbor room, and our direction. If it's not valid, then we need to go back up to this for loop because the direction that we found is not an available direction. We can take our available directions. We can remove this random direction here. Then actually what we want to repeat is this find neighbor. Let's promote this random direction to a variable so we make sure that when we pull it off here, here, and here, we're getting the same direction. Call that random direction. Then we'll want to get that random direction. And we'll want to use that for these instead of this. Move this over here, cut this set line, pull this up here for the set line. So this long line here is our set room. We don't have to pull off that and drag it along a random room variable. Hook those up at those 3 locations and get rid of this long line here that was making everything a mess. That's neater and clearer. We can also do that here with the random direction. And then it helps us get rid of a lot of those crisscrossing lines and makes this look a lot neater. So in this false case down here, after we've removed that available direction, we want to loop back around here to this get random direction. Let's hook that up, and then we need to make that a little more like a loop. Okay. Think that all will work. The only problem here is if we run out of available directions when we loop back around, we might have an issue. We want to avoid a situation where there's no rooms available and we're trying to continuously set this and this will continuously fail because there's simply no available directions to pick. So let's check for that situation. To do that, we just need to check that available directions length greater than 0. And we can do that in both these cases. And if that's true, then we're good. If that's false, I actually want to go back to this for loop and pick a new random room. I think we can just hook that up. In that case, it means that a room should have all 4 directions filled already. And so we can go back here and we can pick another room to add our random door to. And since we're calling our macro add doors here, when we're done with this loop, our random doors are added. So where we want to add this was in our execute with context. After this while loop finished, we want to just add in our random doors here. We'll go add random doors. And we want to make sure this execute pin is going to work. So on our completed here, we want to return. And everything else loops back. So we should have a completed logic loop here. So we should have 4 extra doors. Take a look. It looks like we are getting extra doors because normally there would be a single pathway through all of this. And you can see there's doors connecting down and across here and here. We do see this door here, which is not valid. So we've got a problem in our find neighbor. So we're getting an invalid direction here this way, but otherwise it looks good. Let's see if we can resolve this. Back in our find neighbor, what I forgot here was that we need to use this is valid neighbor down here as well. So this will be the case for both of these, that we want to test this room index for this as well. And if both of these are true, then it's valid. This is testing if it's greater than maximum index or less than 0. So let's AND these together. All right, we don't want room index there. We want the calculated room index. Oh, and we're not returning that neighbor index here. That should be this guy. Hook that back up there and also run that into is valid neighbors. And then same down here where it's this -1 going down here. Then this and this together. Let's flip those. File and save and take a look. And yeah, that got rid of this. So now if we say extra doors 0, we'll see those extra doors are gone and we're back to our single path through. We can see we go through this way and we can get to this room from here and here. And then if we add those back in, let's add in 2 extra doors. And then we have a path this way as well. That's working nicely. Hate this crossing line across here. I'm just going to take this modulo here. I'm going to copy it down, reset it up down here. Not quite as bad. That takes care of adding the extra doors. You could also use this algorithm to simply add random doors as opposed to using the maze algorithm. If you wanted to do that all randomly, you could simply loop through all the rooms and add a random door. But I think the maze algorithm adds another level, which I like. I decided to do it that way. The last thing we wanted to do is add a ceiling. If we go back out to our PCG level, we can remember that we were passing our floor mesh and our wall mesh into this subgraph. We're going to want to add a ceiling mesh. We don't necessarily want the ceiling to be the same as the floor. If we go to BP level, let's actually add a category for meshes. We can keep this all grouped together. So now our floor mesh and our wall mesh are in that category, and let's add a new variable here. I'm just going to duplicate the floor mesh and we're going to call this ceiling mesh. By duplicating that, we have our static mesh type, we have it visible, we have it in category mesh, file and save. We didn't have a default value for floor mesh. We won't set one for ceiling mesh either. I am going to use the same one for my floor mesh for this demo, but you don't have to. Then in PCG level, get actor property, and we'll get the property ceiling mesh. Set the name to ceiling mesh. We'll go into our PCG room, click on inputs and add an input. We'll add ceiling mesh as an input. We'll make that of attribute type. Attribute set will not allow multiple data. Save that back to PCG level and hook that up. Now it reminds me we need to randomize our room type as well. For the ceiling mesh, we want to do the same thing we're doing for our floor mesh. So this is our floor logic right here. Let's add a comment to that. My plan was to copy and paste these nodes right here, but when I do that, for some reason, it's crashing Unreal. These are the steps we want to take to add our ceilings. We're just going to have to recreate that sequence here. So let's create a points grid. The grid extent is the same here as below. Cell size is also the same. Bring that up. In the output, we want to modify the extent, dense modifier. We want to use the extent from this half. Copy that up. That steepness, we should be able to copy this node. And we want to copy points. This is what we're going to change here. Our target is not quite this target because we want to move it up to the ceiling height. Let's deal with that in a minute. Let's copy this add attribute mesh up. And that mesh is going to be our ceiling mesh. And then we want a static mesh spawner. And those settings for the static mesh spawner should be the same as this one. So by attribute, that attribute name is mesh. Save that, and then we need to figure out our target. So for our target, we can take this center break vector attribute, and the attribute we want to break is the position. The X and Y for the position are what we want, but the Z is what we're going to want to change. And for the Z, we're going to want the top of our walls. We never figured out what our wall height was because we haven't needed it before this. So let's go back out to BP level. We can do the same thing we did here with the floor mesh to get our wall height. So this get bounding box. So let's get our wall mesh, hook that up there. Then we want to subtract the min from the max, just like we did before. This is going to give us actually both our width and our height. So if we break this, the resulting z of that subtraction should be our actual height. Promote z to a variable. We'll call that wall height. Make that visible, file and save. Then in our PCG level, we'll need to get actor property. And again, we can pass that into our room, add a new custom input, call that wall height, an attribute, not multiple data. After we break this vector attribute, we then want to drag this over and make vector attribute. In our break vector attribute, if we change this output target to just none, this was originally source, we want it to be none, then it'll line up with this make vector attribute. And this make vector attribute, we want a vector, not a vector 2. So we have a z value. And then we should be able to hook our wall height up there. Yep, allowing that. No clean way to get that up there. And then we'll take the output from that and hook it up to our target. Save that, go back to our PCG level, hook the wall height to our input. No ceilings. This make vector attribute is working. If we look at this, we'll see on our output, our position is the same as what we put in, but we're not outputting position, we're outputting vector. Our vector over here is taking our vector z correctly. So this copy points is looking at position as the target. So we want to set this vector attribute as position. Save that. Okay, now we're getting a ceiling, but we're only getting one. This create points grid, since I didn't copy up this one like I wanted to, I forgot to uncheck this call points outside of volume. So we're only getting a single point. Now we're getting a bunch of points. Good. Now it looks like we're getting a full ceiling. There we go. All right, I do have a player start in the world here, but it's above the ceiling. Let's move that down. Proper test. All right, got my player start inside the room here, and let's hit. Now we have a proper ceiling. We can see it's quite dark in here, but we don't really have proper lighting. So that's not really surprising. Our doors are working. Navigate around. Looking quite functional. So to add in our room type randomization, there's a few different ways we could do this. One way would be to go into our PCG room and just randomize the room type. But I think it would be better if we have a setup that allows us to expand what we're doing with our randomized room type, because for myself, I'd like to have a weighted random, have some limits, have only one of some rooms and more of other rooms, and limit how many are of each room type. To do that, I think it's going to be better to create a function here in our PCG level, probably right here after add doors. We can add another function here, which will allow us to add those randomized room types. And then later we'll create some data table information that allows us to do all that weighting and limits, but that'll be for another video. For now, I just want to get it set up, create a function in here, and then we'll have to extract that information here to go into our room types before we use it inside of our room graph. Let's go into our content browser and create a new blueprint function. This will be PCG blueprint element. We'll call that PCG BP underscore room type. And let's open that up. I want to keep this PCG BP room type as simple as possible. So let's set up our execute with context. Go into override, get execute with context. We'll break this. And then we'll hop over here to our room props. In our room props setup, been a while since we looked at this, but we got our context here. Then we did our data table stuff, which we're not going to need right now in the room types. But what we do need is this stuff down here where we get the input pin, we loop through our inputs and pass that off to the point loop body, and then we make our output. And then in our point loop body, we'll add the new attribute, just like we did here. We won't need any of this stuff, and we'll just set the attribute. And that should be all we need. It'll be real similar to this. From our execute with context, let's grab this content and let's grab all of this. Let's hook this up. Make sure we promote this to a variable. That's our in context. Our in collection is from this input. So let's hook that up. And then this stuff makes all our output in the correct format. Let's hook that to the output and connect up this pin. File and save that. And then we also want our point loop body. Back to our room props, let's go to our point loop body. Here we create a string attribute, a bool attribute, another string attribute. We don't want that because we're going to create an enumerated attribute, and we do a random weight. Let's grab this. We're going to want to do something similar for our random. We pull off this out metadata and we search for create. We can see the attribute types that we can create, and there is no enumerated type, which is unfortunate. So we could convert that to a name or a string or an integer. I think we're going to use an integer, and I'll show you why I made that choice. When we use this inside of room props, we compare against the data table room type here. And for comparison, there's actually an integer behind every enumerated type. So we might as well just compare those numbers. So we'll switch this to a number type and compare against that, and that will work better than converting to a string, and then we have to do multiple string conversions on both sides. So I think the integer type will be the best for us. We'll call this property room type. And for our random, we want to hook this point up here. This isn't going to be a random weight. Let's rename this. For the size of this, we obviously don't want sum of weights. We actually want the number of entries in our enumerated type, get number of entries in room types. So that's perfect. And then we just want to set our integer 32 attribute. Set to that value, the attribute name being the same. And we need to hook our endpoints to our outpoint and return a value. And this needs our metadata and our point data hooked up. Make sure we hook that up. Drag the metadata in here, grab points from here. In our class defaults, let's expose to library level. And now out here, we can move this over, and then let's get that room type, that up here. Oh, I didn't add the custom inputs and outputs. Let's do that. This is in our details as well. Custom input pin, endpoints. Make that a point. We don't need multiple data. And then for outpoints, same thing. Add points, not multiple data. File, save, back out here to level. Now we can put this up here. Take a look at the inspector. Here's our room type here. So perfect. That looks like it's working. So then to get that attribute, I think we have an easy way we can do that. Because the point where that is added is this room extent, what we can do here is we can get attribute from point index, and then we can just pull this point down, and the attribute we want to get is our room type. And then instead of that room type attribute being hooked up here, it's hooked up here. And hey, look, our room just changed, and we're getting our different room types, just like that. To take a look at this, I just cleared that static mesh from the ceilings, so we can see inside. We can see that all these rooms are spawning in as different types, and that that's working properly. We're getting all our doors connected between everything, and everything is looking perfect. Since I split 4 up into 4A and 4B, we have a little more time in this video for 4B. I thought it'd be nice to add some additional control to the room types. So let's add a min and max quantity for our rooms here. So for this setup, I want a data table. Go back out to our PCG folder, and we can just add this here. We'll need a structure for our data table. Right click, blueprint, structure. We'll call this SDT room types. Let's edit that. What we want here is our room type, and that's going to be of type E room type. And then we want a min, it's going to be an integer, and a max, that's going to be an integer. Save that, and that should be all we need. And then we'll create a data table, miscellaneous data table. We'll select our SDT room types. We'll call this DT room types. And then for this, we're going to have a row for each of our room types. So we already have one there for the library. Let's go ahead and add in armory, dungeon, and well. And for each of these, we want a min and a max. So for our library, I want to have at least one library, but at most I want to have 4. We'll set this up this way and make sure these are working. I'm going to set no min and max on that dungeon. And then on this well, I only want one of those. Now in our PCG BP room type, we have this set up here with our execute with context, our point loop body. So in our execute with context, we can start out with the same thing we had here in room props for our data table. So let's copy these 4 nodes over here. So we want to get the data table row names, but we want the new data table. And we're going to loop through those, and we're going to get the data for each row, and that needs to be the same type. And then we want to break that. So then we want to create a couple of variables. We need a min array. This will be of type E room type, and it's going to be an array. And then we need a quantity room types. For that, we want a map. Yeah, just like this. So map from E room type to integer. Then we want to do this before we do our point loop body. I'm going to go ahead and attach it here in place of this execute here. And what we're going to do here on our row found is if min is greater than 0, we're going to do a branch. In that case, we're going to want a for loop. For our true, we're going to go from 0 max, and we're going to add that to our min array. So what we're going to do here is we're going to add one room type entry for each room and desired number to our min array. That way this array should have the right number of entries for all our minimums. So now that we have our minimums, let's move this over and make some room and add a comment to that. Now we want another map. We can duplicate quantity room types and call that max room type. Both these arrays are indexed by our E room types and contain an integer value. Get quantity room types and add to that map. What we want to add to that is our room type and min from our room types data table. This array tracks how many rooms we've added so far. And since we've already added min number of rooms, that's what we want as the quantity. Let's add a comment to that as well and make it a different color. After our quantity, we want to set up our maximum map. We'll add to that only when our max is greater than 0, so we'll need a branch. In order to keep our lines neat here, let's invert the logic and use a less than or equal to instead of a greater than. Then we want our true branch, which indicates no maximum, to hook directly to our minimum. And our false branch means there is a maximum, so we'll use that to add to our max room type. And for that, we want the room type and the maximum. Oops, I see that I accidentally brought the max value to our minimum logic. Let's replace that with the min value. And then we just need to carry on after the add to the minimum logic. Let's comment our maximum and set a new color. Now let's make some space below this, since after we assemble the quantity, max, and min, we'll need some new logic. Currently, our min array contains our minimum number of rows, if that's set. Let's say we have 5 minimum rooms, but 10 total rooms. If we now fill that array up to 10 rooms, then it will contain all the rooms we need. And we can simply randomize the array and pick from it when we build another room. So let's rename min array to random room types and add the logic to fill that up. To add the additional rooms, we want to check the length of our random room types and compare that to the length of the input points. So let's get our points. Those points are in index 0 of the endpoints. Then we'll use a get point to get the full array of points. And that's what we want the length of to compare against our random room types length. So if the length of random room types is less than the length of our points, then we'll want to add to the array. We want to keep adding to that until that test is false. So we can use a while loop to do this. Inside our while loop, let's get our quantity room types, and then we'll need the keys. We want to get the key from the current index, so let's create an index variable. And with that, we want to find the value stored in our quantity room types for that room type. Now we can compare that to our max room type to see if there are more of that room desired. We find the max of our max room type using the same key. If the quantity room type is less than the maximum, then we'll want a branch. If that's true, then we'll add more of that room type to our random room types array. We'll also need to update our quantity room type, which we do with add for maps, and hook up the key and our current value plus 1 for that room type. This logic is correct only if there is a maximum value set, because we only added values to the maximum room type if that value wasn't 0. So we want to check if we found a max value. If true, we run the check, and if false, then we can add a room as there is no maximum value. Then let's connect our add for quantity. Then we want to increment our index, so we'll add a different room next time. Now that we're incrementing our index, back at the beginning of the loop, we want to check if the current index is greater than the last index of our keys array. If the index is greater than the last index, then we want to set it back to 0, and we want to do this check after getting our keys. When we find that our current quantity for a room exceeds the maximum here at this false branch, we can actually remove that room from the quantity room types. Because we're getting the keys from that map, we'll no longer try to add rooms of that type, and that will make our loop more efficient. Let's add a comment to that, fill up random room types, and set a color. Our array isn't random yet, so after our while loop completes, let's add a shuffle to our array to randomize the order. Then we can proceed from the shuffle to our for loop for our points and the point loop body. Inside the point loop body, we first want to create an int32 attribute called RoomTypes to add to our points. Since the points can't support our enumerated type, we'll use an integer to represent that. Since our random room types array is already random, we can just get a reference to index 0, and this is our room type for the current point. We'll want to convert that to an integer from a byte, and then we'll set our int32 attribute to that value for our room type. Then we'll want to remove the index we used from our random room type. Because Unreal implements arrays as a linked list, it is efficient to remove our index 0, and it won't have a bad speed impact to re-index the array. Then we need to connect our in point to our out point and check return value, and our point loop body is finished. Now, if we test this, we can see there is an error. There are 2 of our well room, which should only have a maximum of 1. Let's take a look at our min and max. We'll see that in our min setup, we're looping from 0 to our min value, but really we want to loop from 1 to our min value, since looping from 0 to 1 will result in 2 values and not 1. So let's fix that. So there's also another bug here that's not quite so obvious. When we check here for our last index, this order that we're checking is incorrect. These are inverted. So we want to actually check that this last index is less than current index. And if that's true, then we'll reset this to 0. So we'll make this a less than. And also for safety, we should check that this quantity room types has information or this loop will fail. So let's add a check for that here. Get our quantity room types. We'll get the length of that and we'll make sure that's greater than 0. And then we can AND that together with our current test. The Boolean and if both of those are true, then this loop can proceed. We're going to call that done there for episode 5. I want to separate the rooms out and create the dungeon layout with hallways. It's going to be a while till I work on that. I want to take this setup and I want to start making a game out of it. And so I'm going to probably produce some shorter content off of that. Some of it will be for this PCG series. I'll also be creating some new types of rooms for my game, as well as setting up multiplayer. So I'll create some devlog content and might generate some new video content from that as well before producing episode 5 for this series while I build my new prototype of my game. As always, make sure to subscribe for more content, like the video, and if you're able to support the channel, please join my Patreon. If you encounter any issues or have questions, please post a comment and feel free to join the Discord. Thank you, and I'll see you in the next video.